Okay, so hello everyone. So we want to start with a bit of one example of JUnit. So JUnit, I'll just show you how to do the basic testing, right? So more details you can find on the tutorial, but I'll show like given a code base, like how you can find out the errors in the code, compiler errors of the the runtime. I should not say runtime also uh, the logic in the error in the logic rather, right, the bugs in the code. So let me go for it. So this is my Eclipse editor IDE. So I want to start with Java project. So you can see, right, it's visible, right?
Yes,
Yes,
it
yes.
is visible. Yes, yes.
Okay. Okay, so let me take a sample code. So sample code.
If we can take from GA1 question 9 itself.
I'll do something which will cover everything, right?
Okay, thank you.
Okay, so I'll have, where is the sample example? Sample code here. So here in the source, I can add a file. Sorry, I want to add a class. So I want to add a class. Um, calculations. Calculation. Okay, so it's a very simple thing I first do. I vet int a comma b. I'm having two instance variables. To initialize them, I'll have a parameterized constructor. We'll have this int a, int b, along with this dot a equal to a, this dot b equal to b, and I can have int add, which is supposed to return the result a plus b. So this is the class I want to test, right? Rather, I want to test the method add, if it is working fine or not. Okay, so what I can do, um, we'll go for others, right? Here you'll get JUnit test case. Next, we take JUnit 4, right? We are covering this one, JUnit 4, and I want to test the class named as a calculation. Let me take the name as a test calculations. Right? Let's finish. So it's say add it. It will be added to my project. So we get it like this. Okay. So I need to test the calculation class. I've done class name, public class name.
No, we used calculation as the name while creating it. We missed the L.
Where?
When we created the class, instead of CAL, we just write CACU.
But here it's correct, no?
No, no, here also, I mean, CACU is there. So that is okay, no? I mean, whatever name
Uh,
we gave,
no, no, it's okay, but I'm not able to find out where I've done the mistake. That's why.
CALC it should be, you wrote CACU while creating the class. The spelling in creating the class, that L was missing.
No, that's okay, but Okay. Here I didn't write this. Okay.
Yes.
Okay. So I was not able to find out what I haven't done.
No, so when we are creating this calculation object, yeah, now it is okay.
I'll do that. You can do it in easily in the editor. Okay. So I got confused like what I have done wrong. Yeah. So these are the test methods. So I can just write them as a test case 1, 2 like this. So I need to instantiate the object first, new calculation, right? And I can pass my values. Now to test it, the most popular one is assert equal. So assert equals. So where
Excuse
you
me, sir.
write the
Sorry to
expected
interrupt.
result first. Hello.
Yes, sir.
First
Sorry
write.
to interrupt.
Yeah.
Could you please go back to the calculation class once? I just want to take a look at that. Okay. So we have this. All right. All right. Sure, sir. Yeah. Thank you. Thanks so much.
Okay. So if you do run it, so it's basically show a success because everything gone correct. So let me go back to my code. Suppose I've done some mistake, right? So we say it's always better to have multiple test cases because sometimes single test case cannot give you the correct result. Suppose I have given 2 and 2, even my code is wrong here, right? So it gives me a okay.
You have to update it in
Okay,
assert
sorry,
equals.
this is 4.
Yeah.
Expected result is 4.
So because addition and multiplication
Yeah,
both
yeah.
gives us 4, then
So
therefore.
yeah. But in that case, it's better to have multiple test cases, right? Where you can create another test case, and here you try with 3. So your expected result has to be a 5, and if you try with this, right? Uh, try with this.
The decorator is missing, sir. In the test case 2 method, you have
Yeah,
to add the decorator
yeah,
test
yeah.
so that it is included. So please note that for others also, you have to,
Yeah. So if
for
you
all those
click,
methods, yeah.
yeah. So if
Yes,
you
sir, please
click
continue.
on this, so see the first test case is clear. There is no trace. But the second one, if you look at, your expected output was 5, but what you're getting basically a 6, right? So that is got identified. So now this is, if you want to check the equality, you can also check for inequality. So if I say uh, test case 3, if you say if you multiply anything with a 0, say you say it should not be equals to, it should not be equals to 1, right? So that means if it is anything other than 1, then it returns a true, right? So that way, if you go for the first test case, it is correct. The second one is already wrong. The third one also is a correct because it will return a 0. So which is not a 1, and you are checking for not equality, right? Then next we'll check for true, assert true. Assert true basically checks for a conditional statement. Okay, so how do I do that? We say obj dot add equal to 0. This is a condition, right? Still 4. So if you look at this condition, this is a true condition. So it's a true condition. Now you can give a false. Okay, true also you can use it like this. Suppose I give a 5. You say it should be greater than 0 if I multiply with any value which is more than 10, right? More than 0. So this is also a true condition. So this is also true, but if I do the reverse, if I do 6, I say it should be less or equal to 0. That's a wrong, right? Because 2 into 10, the value should be 20, but here I'm expecting the value which should be less or equal to 0. So this should generate a error. So if you go here, right? So only for the assert equals and not equals, you're going to get this expected output and all. For assert true false or assert null, it do not show any output, but it will show this is the assertion error.
So asset false will also be there.
Yeah, assert false is also there. I'll do that. Okay, so I'll do the 7. I'll make it as assert false. Right. So now in this case, assert false is again true, correct, right? Assert false will be now correct. So we got the 7 case, it's a correct case. Okay, and another will see that null and not null. But for addition, it's always not null. So I have to show another example. So I'll show that. I'll just show that.
Why addition always not null?
I'll tell you 1 minute. So not null, right? So I'll say obj dot add. So this will return a not null value because it's a 20. Right, it's clear. But people normally make a mistake that probably you are right now making. That is, suppose I multiply with a 0, right, and check for a null. Remember, 0 is not a null, right? So if you do addition, you'll get a value, right? So definitely it could be 0 or anything else, but it's not going to be a null. That is what I mean to say. So in this case, it will give a error because it gives a 0, but 0 is not a null. Is it clear?
So will it be in subtraction? It will be null.
No.
Correct.
You'll get a 0, right?
In subtraction
Zero is
also
not a
we'll
null.
get 0. Yes.
Yeah, but 0 is not a null, right?
Correct. There is a value 0.
Yeah. So I'll also show another example. I'll do another program to show a scenario where this null thing will come, right? So let me name it as a string.
So null will happen when we remove everything from a string.
Or object also the same thing can happen. So maybe I'll do a organization.
Excuse me, sir. So can we use the same project and just add the class there and just?
I don't want to do actually. Actually, we can do it.
We can do it,
but
right?
Yeah, we can do it. But the thing is like, it's always a good practice initially. Have a main check your program is
Yeah.
correctly running or not.
Correct,
You cannot have two mains in the same project, right? So that's
True,
maybe
true,
you can create it as a different project initially. But what I have
True.
created, I haven't written any main. If I add another class, that won't create any problem.
I understand. Okay.
But for the time being, it's maybe better to avoid that. Yeah.
Yes, yes, I understand. Okay.
Okay, I'll have an employee class. It's a very common kind of class. So let me have a private int ID and private int name. Right. I'll have a hobby constructor.
Should be
Sorry.
strings, right? I'm sorry.
Yeah. Sorry.
The
Yes.
name, yeah.
I'll have this public employee parameterized constructor now. So I give this ID and string name. I wrote here ID equal to ID, name equal to name. Okay, and I have also a method, right? I'll also have a method that is int get ID, which will return ID. I'll have public string get name, which will
Excuse me, can
return
everybody else please mute?
our name, right? I wrote my class.
सर्च लगाएंगे प्रॉब्लम सॉल्व करने की कोशिश करेंगे आंसर आ जाएगा ठीक है आंसर नहीं है
Okay, so I'll add new other next. Here I have test employee. So I need to take the. So make it JUnit 4. Okay. So I want to test my employee class. So I can have employee E, right? So E I have to define. I'll have 10 and half none, right? And what we want to do, we want to check our methods are working properly or not. So let us try to check with the ID, right? So I'll have this assert, sorry, assert equals, sorry, assert null, assert not null, rather. What is happening? Okay, so assert not null, and I call e dot cannot access the compilation unit. What is that? Run it once. I don't know.
Index out of bounds it was showing.
Oh, I haven't run it only, right? Okay, so okay, let me check out. So I'll have e dot. Even if I'm clicking anywhere, it
There
will.
appears to be error in the employee lines, line number 6. Not here in the test employee or Java class. There itself it appears to be in line number 6. Why is that employee not? I think you need to have a access modifier there, right? For the employee
No,
thing.
it's not mandatory, right?
Yeah.
Public. No, it's not required.
Here
Let me see it.
it should be fine then.
It should be fine, right? I don't have this. Which one it is called? Compiling. Okay, let me compile this first. Why it is directly taking this file?
Okay, there is one more class having the same file name, sir. Test employee. If you see the
No, that's just show it outside. It is the same thing. They're the same thing.
Okay, I see.
Don't know. Hold on a second. But P dot, no, still this problem is coming. Let me don't save it. Okay, so this is fine. I want to add new other test employee. Okay. Employee.
So if you don't give it, so then it becomes default, right?
Yeah,
The
that's also possible to work. Yeah,
right.
it's not for that. It is some other reason it's coming.
Yeah.
Employee,
Possibly
then
something with ID maybe.
and now it's working. Cert. I don't know what happened. Not null. It is e dot get ID. So will it give true or false? Will it pass the test case?
It will pass, no? I mean, ID has a value, so not null will give true.
Yeah. So it's a not null, right? Okay. Test 1. Test 2.
That decorator you have to give.
Now, yeah, decorator will just sometime forget to copy it. Now,
Not null. I mean, if name is coming, no, after all.
see, now it's giving an error. Why?
How it was defined? Yeah, defined it was name. But name. String name is there. Return.
Okay,
name.
I'll give another clue. Okay. Okay, let me write another test case. I just wanted to show why so many options are given, right? Okay, so again,
This one is a nice example, by the way.
I want to use equals, right? Now I want to have this 10. Now is it okay or not?
10 equal to 10. I don't know whether it's referring to memory location or values.
See, even this is wrong. So now check the code why these are wrong. See, this will start working if I give her this. All are working. So what is the difference? If I don't give this, ID going into ID, right? So this ID is this ID. What about this ID? Which ID this is? This is this or this? Hello?
So this not belonging to
Yeah,
the
so
object
all are
deleted.
local, right? Until unless I give explicitly. So this value is going into this value only, nothing coming into ID. So default ID value is 0. And name is null. So that is the default initialization in Java, right? the numbers will get 0 and strings will get null. So if you just do this, if you just
Okay, if
put
we
your,
change the value there for 0 and null, then it will
yeah,
pass.
yeah, public static void main. I have this here, yes, and I try to do system.out.println e dot. I need to create an object. Employee equal to new employee 20. So it's get ID dot get in, right? Just run this here. See, the output is becoming 0 and null. So these are the default initialization. Either you give this, or what Madhavan sir taught, you give a different name over here and do it like this. So now it gets this correct values. And if you go for testing this program, all pass correctly. Is it okay?
Okay, so because of same variable names, it was getting confused, kind of.
Yeah, it's no, it is getting not confused actually. See, the thing you have to remember, if there is two ID, so this is a function, right? Within the function, there are basically two ID. One is local inside the function, which is the parameter. Another is global to the function, which is the instance variable. Now, in any scope, local will override the global. Local
Correct.
will be always prioritized. So if you just do ID equal to ID, both the IDs, so if you just drag it, you can understand where it is going. It is going into this. But the moment you make a this, see, this highlight is going somewhere else.
Yes,
If
yes.
I just drag it, this, but if I drag this, it's going there. Either you change the name, but if you want to keep the same name, use this.
Got it. Yeah, actually, when you were writing earlier, I thought in previous example you wrote this dot a equal to a. Here you are not writing. Understood.
Okay. Okay. Next, we're supposed to go for. So I'll take some time. I need to get one question. Okay, maybe I can follow what a graph ma'am has used. That will be easier for me. So this is something I have. I'll explain like how these are derived. Right. Okay, so last class Java was going on. I'll do it over here. Let me take down the graph first. So I have 0, 1. This is the initial node. Then 2, 3, right? Then you have 4.
No,
Okay,
1, 2, 3 is opposite.
okay. 1, 2, 3 is opposite. Then 4. Okay, so this is a self loop. 5. I took everything, right? Yeah. Okay. So now the steps are as follows. Like you need to first consider the path of length 0. 0 length. So what will be your paths? Okay. So all the nodes, right? 0, 1, 2, 3, 4, 5, 6. Now the path cannot be extended. I'll mark it as a final. This is the exclamation sign I give to mark it. This path cannot be further extended, because since it is a final node, there is no need to extend this. Right? Now, from here, I'll go for deriving the path with length 1. Okay. From 0, what you can get? 0, you can go from 0 to 1. And from 0, I won't write this. So it will be 0 to 1. And I can also go 0 to 4. Anywhere else with 0, one path? No. From 1, where I can go? From 1, I can go to 1, 2. From 1, I can go to 1, 5. Right? 1, 2, 1, 5. From 2, where can you go? From where 2, you can go to 3. Is there any more path from 2? No. From 3, where you can go? From 3, you can go to 1. There is no more path. From 4, where you can go? From 4, you can go to 4. And if it is a loop, I'll put a star. I'll say I won't extend this further. And from 4, I can go to 6. Now look at this path also cannot be extended, because I already reached the final node. I've already reached the final node. Okay, from 5, where I can go? From 5, I can go to 6, which also goes to the final node. So that's all. 6 I cannot do, because 6 I have already put this final mark, right? Now you need to deal with only the paths which are neither asterisk nor the exclamation. So I'll go for now 2 length. Okay, so maximum how many length I need to check? Since I am having 7 node, I can maximum have length
6.
6. Yeah. So I have to check maximum 6. But before that, it may be solved. Okay, so 2 length with 0, 1. Right? 0, 1, I can go 0, 1, 2. I can go to 0, 1, 2. With 0, 1, I can go 0, 1, 5 also. Anything with 0, 1? No, I think. With 0, 4, where I can go? I can go to 0, 4, right? 6. But this is this thing. Can I go 0, 4, 4?
Yes.
Remember,
Why?
I cannot do
Why?
that, because I need to consider only the simple paths. What are simple paths? In the simple paths, no nodes will be repeated. No node will be repeated. Only one case they can be repeated. That repeated node is the first node and last node. So this is allowed, but there cannot be any intermediate node, the repeated node. So
Okay,
this
so
is,
that is possible only in case of path length of 1 unit.
yeah, if it is the, no, we can have this 4 1 2 again 4. So this is the repeated item is the first and last element of the path. They cannot be repeat intermediately. Is it clear? The
Correct. So
repeated item
if
should
it
be
is
the first and last.
so if it is the path length of 1, then only we can take self loop.
No, normal loop also could be there, right? I
No, no,
can take 1 2 3 1, right?
no, that
That's a
will be
simple
path
path.
length of 4.
1 2. No, I'm just giving example.
Okay.
With 2 you can have like this. You can have like this. In this situation it is not there, but suppose there is a path, right? 1 to 1.
Yes.
You
Yes.
can take it. It's a simple path. But what you cannot have, you cannot have 1 2 2, because this 2, the repeated node is the intermediate node. So this is not a simple path.
No. Basis that definition, you said between the same node there shouldn't be any intermediate node. But in case of 1 to 2,
No, I told if it is a repeated node, then it has to be the first node and last node. It cannot appear in the middle.
okay, got it.
So it is 046. With 04, can I get anything more? No. With 01, 012, 015, nothing, right? With zeros, okay. With
Part
1
2 is
2,
covered. Yes.
with 1 2, what I can get? 1 2 3. With 1 2, anything else? No. With 1 5, I can have 1 5 6,
6
but
with
that will go me
exclamation.
to the final. Yeah, nothing else, right? Now I'll go for 2 3.
2
With
3 1.
2 3, I can go to 1, right? Anything
That's
with
it.
2 3? No.
That's it.
Yeah. So with 3 1, I can have
3
3
1 2 3 1 5.
3 1 2. I can have 3 1 5. Anything else? 3 1? No. Okay, so these are, I don't have to consider, right? Okay, so I have to take now 3 length. I'm taking it over here so that I can see whatever things are there. Okay,
4 4
so
6 will not happen only because of that simple path thing.
yeah. So 0 1 2, starting with 0 1 2, what I can have? 0 1 2, 0 1 2 3. Okay. Now just look at this path. I'll say this is
So from all the whatever path of length 2 we generated, now all those paths we are extending to possible
yeah, what are
extension to 3
extendable
paths.
means that do not have a exclamation or star, I'll extend. But see, here I have given an exclamation. Can you tell me why? Because 3 is not a final node, right?
Yes.
But why this exclamation? See, after 3, I cannot extend anymore, right? If I try to extend, I'll reach 1. So that will violate my simple path, right? See, I have 0, 1, 2, 3. Can I further extend this path?
If 1 again comes, then that 1 is in the middle also.
It will violate the simple path, right? So there is no way to extend this path. So that's why I put a exclamation. So this reaches the dead end, this path. Okay. 0, 1, 5. I can go for 0, 1, 5, 6. So that also reached the end. This is already reached the end. 1, 2, 3 I have to check for. 1, 2, 3,
No,
what I
then
can have?
we can't
1,
have 1.
2, 3.
1 we can have
1
again.
I can have because it's a
Yes.
loop. I'll put a star. right?
No,
1
I
by
mean,
6.
what? So here we could do, just because one was starting, we could do it.
Yeah,
And
starting and ending is the repeated node, right?
correct.
So repeated node appear on the starting and ending, that is allowed, but they cannot appear in between.
Understood. But what is the logic, and why is the logic like that? Or is it just a convention?
No, it's the logic. It's the definition of the simple path. If you have gone for the definition of the simple path, it's the definition. That's why it's called the simple path.
Correct, correct.
Okay. So now 2, 3, 1. Can I extend it?
Yes, 5.
2, 3, 1. I can have 5. Okay. 3, 2, 1. 2, 3, 1. Do I have any more things? 2, 3, 1. No. Okay. 3, 1, 2.
3.
3, 1, 2, 3. It will be a loop. I'll put a star. 3, 1, 2. Do I have anything? 3, 1, 2. No. 3, 1, 5.
Yes, 6 and exclamation.
3, 1, 5. Yeah. 3, 1, 5. 5, 6 with exclamation. 3, 1, 5. Okay. So still I have left with one path which can be still extended, right?
2, 3, 1, 5, 6.
So I'll have 4L. Yeah. 2, 3, 1, 5. Let us see what I have. 2, 3, 1, 5. So it's 6. Just one. So that's all. Right. So all these are simple path. So if say somebody how many simple paths are there, you need to add all starting for 0, 1, 2, 3, 4. All are simple path. Right. Okay. Now I'll look for the prime paths. Prime paths are this one which are okay. Prime paths we'll consider one by one. Prime paths are which one? Which are either having the exclamation. Okay, let me write it down. So I'll have the prime path whenever you're considering, you have to consider from the highest, that the maximum size one, because we say the maximum will subside sometime the minimum one. So the prime paths, I'll list the prime paths. Okay. So first I'm getting 2, 3, 1, 5, 6. So this is done. Now I can take this one 3, 1, 5, 6. But the thing is this is already
So,
covered, no?
so maximum length simple path is already a prime path.
Yeah, that is already a prime path. Now all this having an exclamation and star, they are potential to become a prime path. But I have to see they are already covered or not. For example, this 3, 1, 5, 6 is already covered by this path. So that's why I start with the maximum. See,
Correct,
this
correct,
2,
correct.
3, 1, 5 already covered is this is already covered into it. So I don't have to take again separately.
Correct.
Now 3, 1, 2, 3. I need to take this. This is not covered. 3, 1, 2, 3. Right. I'll check for this 1, 2, 3, 1. 1, 2, 3, 1. Okay. 0, 1, 5, 6. 0, 1, 2, 3. Anything else? I took this one also. Okay, so I have to go up. 1, 5, 6.
Is
1, 5, 6
subsumed.
already covered. Yeah. 0, 4, 6. 0, 4, 6 is
No,
not
it's not
covered, right?
covered. Not covered.
Okay, there is nothing right here. Okay, 5 6, 5 6 is covered. 4 6,
Covered.
4 6 is covered. 4 4 not covered. See, it's cover basically all the loops, these prime paths. 6 is also covered, right? So I have all. I got 7. I don't know how many you have. 1 2
Eight,
3
eight
4
he has
5
mentioned.
6 7 8. So I missed something, right?
2 3
Just take
1
out
5
after I check
6
everything.
3
4
1 2
4
3.
I got.
2 3 1
0
2 she is taking.
2
2 3 1 2 she has taken.
2 3 1 2 3 1 5. Oh, we haven't missed it, right? 2 3
Okay.
1 2 will be a,
And star. And star.
yes, it's a star, right? We missed it. Yeah, so little careful.
Just
Yeah, so
it is a little time taking thing.
yeah, it's little type taking. So here normally we give that uh, common data kind of question. So you have to find out how many simple paths, how many prime paths. Then you have to find out finally the test path. Test path means the path which will cover this all test criteria. So prime paths are basically the test criteria. So I say this path must be covered, right? Now it's always better approach you start with the maximum, because maximum is upside other one. So the maximum is 2 3 1 5, but test path will start with the initial vertex and end with the end vertex. So I need to cover this 2 3 1 5 6, 2 3 1 5 6. So if I want to go there, test path has to start with anyhow with 0 1 2 3 1 5 6. So this is one path. I have to check 3 1 2 3. Is it covered? No, it is not covered here. So
So
3
then it will be
1
0
2
1
3.
2 3
So I need to take
and
0
0 1 2
1 2 3
1 2 3.
0 1 2 3 1 2 3 1 5 6. I have to come out, right? Okay,
Correct.
so
So
this is
basically
one.
the logic is now in all these prime paths, try to reach the first
I need to
element.
cover them.
Yes, first element of that prime path, and then from the last element of that prime path, go
Yeah.
towards the ending node.
Yeah, yeah. So next is 1 2 3 1. So 1 2 3 1 is already covered. You can see here, right?
Yes.
So I have to check this one. 0 1 5 6. It is not covered, right? 0 1 5 6. So it's a direct path. 0 1 5 6 4. Okay, 0 1 2 3. 0 1 2 3 already covered here. 0 4 6. 0 4 6. We haven't covered. 0 4 6. Then 4 4. I have to have a 0 4 4 6. Then 2 3 1 2. 2 3 1
Covered.
2 is already covered. So we are having this 5. But we may ask what could be the minimum. So in that case, you have to again check any of these are covered by the maximum one or not. In this case, probably it is not, because if you check 0 1 2 3 1 5 6, it is a different path. No, it is not. None of the path is included in any other path. So all are unique.
So
So I'm
could it
getting
be
to
so that the whatever test path we enumerated, one test path could be subsumed by another.
See, sometime what happen,
Because all these
some
prime
loops will be
paths,
there. Yeah, I got your point. Sometime no. In this scenario, it's not happening. Sometime no. You can get a path which go from 0, 1, 2, 3, 1, 5, 6, and you will get another path which will be 0, 1, 2, 3, 1, 2, 3, 1, 5, 6. It will repeat twice. Then you may avoid the one time repetition because two time repetition already covering the one time repetition.
correct, correct.
So you may get that kind of path as two paths. In that case, you may remove one, that one iteration. You practice it. Maybe I'll do another one next day if you are still having problem.
That yeah, now it's clear
Yeah, but
mostly.
practice it. Yeah, you need to practice it. Otherwise, it's forget.
And
Yeah, Apnan, you want to start?
it, and what I was saying that this should go as a tutorial in week 2. The thing you explained nicely, if that can be appended as a tutorial, maybe it will help
Yeah,
other
maybe we
batches.
can do it afterwards. Yeah. Anyhow, it's there on the YouTube. Yeah. I need to understand what is prime path. So prime path is a kind of coverage testing, right? So normally we have node coverage, then we are having edge coverage. So prime path, another coverage criteria where you want to cover all the simple paths inside your graph. So maybe you can go through a bit theory of what is simple path, what is prime path, and follow the YouTube like what I have done. Like what I have done, I try to find out how to find in a graph like what are your prime paths. That was my focus. You may go through a bit theory, then maybe come back. If you still have a doubt, I don't think it will be a problematic for you. If you still have a problem, we can discuss that. Yeah, Afnan, you want to discuss?
Yes, sir. So the previous class, actually, there was a request to come up with an example for the difference between faults, errors, and failures. So that is what I
Okay.
have tried to
Okay. So
demonstrate.
you can do that. I'll be back
Hmm.
in 10 minutes. Yeah. No
Yeah,
problem.
yeah, sure,
You
sure, sure,
continue.
sure. Yeah, sure. Thank you. So before we move forward, is there any question at this point? Okay. So let me start by sharing my screen, and then I'll continue from there. Okay, please let me know if the screen is visible. Is it visible?
Yes, yes,
Okay, sure. So yeah, there is a notion of side trip and tour also. Maybe if time permits, I'll take that at the end. But before that, I just wanted to come up with an example for this. So I have a code here. Is that visible?
yes,
Okay, sure. So what happens, no, in this particular code? This is in Java only. Okay. So there is a method which is named as find last. Okay. So the expectation is that we will be given an array, right? That is int array. It is called x. Okay. And with that, an integer for which we are looking for inside of that array. So let's say we have this array, then we may search for a particular integer inside of that, see if that exists or not, and then return the particular index, note that from the last. So for instance, if I ask for 3, it should not give me 1, rather it should give me 3, 0, because this is 0, 1, 2, 3. So at index 3, 3 occurs. So if I give y is 3, then it should give me 3. That is the thing. So last index of whatever y is. Okay. Is the code clear? Is the objective of the code clear?
yes. The last occurrence of a particular search element it will give.
Yes, sure. So this code has a particular error or fault, as I might say. So we'll come to that, but before that, I just want to show you the example with this particular input. See what happens. Okay. So this is running on this right side, and you can see the output. It takes some time. It will come up. Normally. Okay, so this is now coming up. So this is giving me the right index, right? Because that index 3 exists. Okay, so this is valid, no? This is correct only. So for example, if I give 8 also, it should give me the last one, which is 0, 1, 2, 3, 4, right? So it should be 4. And this seems to be working perfectly, correctly. But then,
Why it is taking so much time?
actually in Replit, this Java runtime takes some time. I don't know why. Something from the Replit side, actually.
Okay.
Yeah. Anyway, so yeah, that is so the our focus is going to be on this method only. Actually, this is from the one of the previous papers, from the one of the previous quiz papers. So this question actually came in there. I thought I'd just take that. Maybe it will help you understand the concept behind that. So anyway, so this is what it is. So just go through this code and see what all it is doing. So okay, we are starting from the last node. That okay. That is why, because we need to find the last one. We're starting I from the last. Okay. And then while I is greater than 0, we are subtracting I, right? Decrementing I rather, one at a time. Okay. Now at any point in time, if x of I becomes equal to y, which is our search element, the element for which we are searching, then we are going to return the index of that particular element. Okay. If the loop exists without this condition being true, we'll automatically get out of that loop, right? And then therefore the default is to return -1, which is to say that that particular element does not exist in the list. Is the logic clear?
Yes. So in this case, we are trying to implement the same thing by returning the first search instance, going in the reverse direction.
Mhm.
The moment we get a match, we will return the index. That is
Of
the
course,
logic.
of course. So because of the fact that you are starting from the right, the effect that it would have is that it will give you the last occurrence. Okay. If we had started from the left, we would have got the first occurrence. But because the objective was to get the last of the occurrence, therefore we started from the
Correct.
left, right. Of course, if you have only one occurrence, of course, it is going to give you the same index whatsoever. So I mean, like, it doesn't matter in that case. But given that there are two or more occurrences of a particular element, then we are interested in finding the last of that, and therefore we are starting from the right of the array. Okay. All right. So the problem here is now that, so I'll try to distinguish. So there is a fault. So before we move forward, can you figure out that fault looking at the code by itself? Because recall the definition of fault. It says that a fault is a static defect or a mistake in
It's
the source.
already there in the code. Yes.
Yes. So before even running, we can try to understand what is the fault, and that is indeed the very first step in order to be able to understand what those other things are. So can you figure out that error or mistake that is there in this particular code segment, particularly this method only, because this is the driver code, so we are not concerned about this, rather this method only. So just try to look at that and see if you can figure out the error that is there, or rather the fault. Because this is a question from the quiz. So this exact code segment was there in the question. You had to read that and come up with the fault, and therefore select the right answers from among the given options. So take it in that sense, because you cannot run the code there and
Yes.
observe
So
the
this
outputs.
it will, if
Hmm.
it will reach to
Hmm.
index 0, but in that case it will come out of the loop itself.
Yeah, that's correct. So can you point out where exactly is the error and what?
I greater than 0. So in the moment
Yeah,
I greater than 0, it will go to the index 1. After that, it comes out of the loop without checking
exactly.
the first index.
Exactly. Whatever you have said is precisely correct in this case. So that is indeed the fault. So you have figured out the fault. Now let's go with the failure first. I'll come to the error later, because error is something that requires a little bit of explanation to be able to appreciate what exactly that means. But I'm talking in terms of the terminologies given in the week one slides. So if needed, I'll come go to that also. But I hope that you are familiar, because we had a discussion regarding this in the previous class also.
Yes.
But I'll come back to that also if needed. So the point is that we have identified the fault now. Okay, the fault is that we're missing the equal sign here. That's okay. Now let's try to come up with a failure. So as you know that because of this very error that we have here, or the fault that is here, because of that the first element would not ever be checked. Okay, so if 4 doesn't exist in all the other places in the array, only in the first place, so we understand that if we give y is equal to 4, then that is going to return us -1, which translates to it not being there even though the element is there. So if I run this, you're going to get -1, as we have
We
discussed.
can simply return not found instead of minus.
Yeah, I mean, yeah, that is okay. Like this is a standard convention whenever we
Yes,
have,
yes,
yeah,
yes, yes.
whenever we are going to return an integer, because if you are able to, if we are looking to return not found or some kind of a string, then we'll have to change that to a string, because we are returning an integer, therefore we're returning -1. So that's okay. That is not the point. The point is that there is an error. You can see 4 exists, right? So the objective or the requirements that this method should fulfill, it is not fulfilling that requirement, because it was supposed to give us the last index whenever the element existed there. But in one case we can see at least one case. There might be other cases, we're not concerned about that, but it so happens that wherever the first element you give here, and the same value you give as the input, then you're going to get a wrong output. And therefore this is exactly what a failure is, because you're able to see that, right? You had a 4 there.
So now here, because of fault, failure happened.
Exactly, because of fault, failure happened, but in between the two things there is this thing called error, of which I'll talk in a moment. So at this point, is it clear? Are there any questions at this point?
No, so in previous class, we had discussed that because of fault, failure happens, but interim an error will occur, then it will propagate to failures.
Exactly. So to get to the uh, understanding of what error means in the context of software testing, at least the way it is defined here in this course, is that you have to understand that at every instance, when the program is running, right, you have in fact in memory a state of the program, right? So is the notion of a state clear to you? What a state
Not,
means?
not very clear.
Not very clear. Okay, not an issue. So I'll kind of try to briefly explain that also. Let's try logging these things. So see, whenever a method is running, right? So there are certain things to think of it in a more abstract sense. You have an input, okay, and you're going to get an output. That's okay. In between, you have intermediate variables that are holding a value also, right? For instance, you have I, that is going to be an intermediate thing that is going to increment and all that. You have this check happening here. This if condition is there and all that. So this entire thing is in some sense is a state, right? Maybe it'll become more clear, but for now, just try to see what all values are there, and what are their actual values of the variables at every instance when the loop runs, because this is the main loop, right, that we are running. So what I'm going to do is that I'm going to just log it. So system.out.print, let's say ln. Okay, so what all we have x is more or less remaining constant, so we can just look from here. X is not changing, so I'll not log that. That's okay. But remember that this is also part of the state, but this is in some sense constant. This reference remains constant. This memory reference remains constant to this particular instance of an integer array. Okay, so you're not logging it, therefore that's okay. Y also remains constant because this is what we are going to search for, and therefore it will remain constant also, as we have given it here. So this is 4. Okay, that's okay. So I'm not logging it. Let's log the other things. So for instance, the things that are changing. So I is changing, right? So I'll just, to start with, I'll just log I. So let's say I plus I, I'll make it like this. So, and then the value for I, whatever it is. So we'll see what all is coming up. And so x dot length is also going to be constant, because we know x, we know what length would be, and -1 is just going to be again a constant. That's okay. Yeah. So the only thing that is changing is I, right? So in an ideal program, think about this. Think about how the program is working now. So we go to the last element. This is how it works, right? So I hope my selections are visible. Are they visible?
Yes.
Okay. So we first go to 8. Now think about how the program should behave, right? This method. So you go to 8, you go to 3. Okay. After that, you go to 2. You go to 3, you check, you check that also. So you go to 8, you check whether it is equal to whatever element is there or not. And that is what precisely we are doing here, no? And we go to 3, we check that. We go to 2, we check that again. We go to 3 again, we check that. And in an ideal program, or the expected behavior should be, the logic should be, to go to the first element also, of course, and then we check against that also. But in the faulty program, the current faulty program that we have, what is going to happen is that we go to 8, we check that, we go to 3, we check that again, we go to 2, and we go to 3 also, we check, and then we don't ever go to 4. And therefore the problem exists. Okay. So that is the thing. What happens is that, you know, if I run this now, you see the values for I and see what happens. So this for us, is going to be the state, and that is holding the values 5. So we start with 4, you go to 3, you go to 2, and you go to 1. So the value for I, at the second last or the last iteration of this loop is going to go to till 1 only, and then it is exiting. Whereas in the correct program, so all these are states, right? This was the initial state where we started with 4. Okay.
Yeah, that is the first iteration.
Right. And the state changed, the values for the variables, the intermediate variables changed, so we made it 3. Then in the next iteration we made it 2. In the next iteration we made it 1, and we should have made it 0 also in the next iteration. So speaking of the internal state, we're not talking about what the output is as of now or what the
Yeah,
code is.
so iteration. So if it length is x, then x iteration should come.
Exactly. So you can think about it in the terms of an state, right? The internal state should be like this. You need to go to 0. Now think about this one other input. So let's say we have 3. Now in the correct program, what should happen? We go to 8, right? We check that, we get a false. We move forward. We go to 3, we check that, and we see that it is matching, right? And therefore we'll return the correct index. Now even if the program is correct, let's assume that this fault is not there, the state is perfectly matching, the behavior of this particular code as I'm running on this input 3 is going to be exactly the same as if this error does not exist. Like if this fault is not
Yeah,
there,
true. That's true.
right?
But still, there is some fault.
Yeah, fault is there, that's okay. I mean, like, but then again in this case, so what we would say in this case is that the error did not occur. Okay,
Correct.
the
Correct.
error did not occur, and therefore there was no failure also. You can see that 3 existed at the index 3, and therefore we are getting the correct value. So my output is my expected output, and my internal state was also valid because I intended to go to 4 and then to 3 and so on. And my behavior was to, whenever the match occurred, we are exiting, and we are exiting here also. So regardless of the fact that the fault existed, we're not getting an error in this case, and our output is correct also. So this is a successful in this case, but in terms of uncovering the error, it is wrong. So maybe we'll try something else. Now contrast this. Please try to contrast this with one other input that I'm going to give. Okay. So what about 1? Okay, 1 does not exist. Okay. So what should be the output? The output should be -1. Okay. So let's see what comes up. It will give us -1, but then again, in this case, error occurred. There was no failure. Okay, because we are not able to observe that externally. We gave 1, 1 did not exist at any place here, and therefore we're getting -1. In the correct program also, my output would be -1, but there was an error in my logic. The logic says that we should go to I0 also, when I is equal to 0, but we are not going there, and therefore the state is invalid in this case, right? Because we had to go. Contrast this with the previous case. When it was 3, we had, what we should do, we should go to this 8, then we should go to 3 and we should exit, and that is what we did. So even if we are
So what should we call in this case? Error happened, but failure did not happen.
exactly, error happened because your state did not work or behave as it should behave in an ideal program, or a valid program in that case, or but in this case error happened because the state, you expected it to go to 0 also, but it did not go there, and therefore error error occurred, but failure did not occur. However, in that case, when 3 is there, there is no failure, no error as well, because that is the intended behavior. Here in this case, your output may be correct, but the behavior was not correct. It is as if you are getting the right answer by doing the wrong thing. I mean, like that. So you are calculating something, it's like multiplying 2 into 2 and getting 4, whereas you had to add, right? So if you go to 2 plus 2, you also get 4, but no, the output is correct, but then again, the logic was wrong, right? So instead of doing 2 into 2, you did 2 plus 2, and you're getting the same output in both the cases. So like that. In this case, you should get -1 because 1 is not there, and you are getting -1, and that is that is a valid behavior in terms of the output. But the error occurred because the behavior was not correct. So when we think of programs, we should think both in terms of the output as well as the logic or the behavior of the program. Okay, so in this case, the behavior was not correct, but of course, it so happened that the error, that the output was correct. But then again, if I make it, let's say, and in this case, like let's say if it is 4, then in this case, error of course happened because it did not go to 4, of course, and that is why the failure would occur in the first place. But you were able to observe that also because you saw that, okay, there was a 4, but my program is giving me -1. So in that case, that was a failure. Is that clear? I mean, I understand that it might be ambiguous, but are the three things clear? So this
Yes,
gives
yes.
us a failure. And for example, if this is a failure, so we will say that this is a error but not failure because the output is correct, but internally the state is not correct. Okay, if we give anything other than that, so let's say I give 3, then in this case, no error and no
Fault,
failure.
but no error and failure. And
Yeah,
in each
fault is,
fault will be everywhere. Yes.
fault is everywhere because that is constant in some sense, right? You have this in the source code itself, right? So we are talking not of that.
Yes.
you
Yes.
you get the difference,
Absolutely.
right? So
Yes.
yeah, maybe this was kind of a toy example. So the state definition that I gave might not fit in very well in this particular example, saying that I should go to 0 and it is not going to 0. But that is what happens, think of it like this. You have a lot of objects, object oriented programming. You have a lot of objects. Some object has some particular invalid state. It should hold the name of the employee as something, but it is holding null. And you move forward, you do something else, and somehow you're getting the right output. But we would say that error occurred. You're getting the right output is not it is not enough to say that the behavior also was correct. Okay, so that is the difference between the failure and error. Failure is the manifestation of an error, the external manifestation. Therefore, you're able to see that because of some error that happened internally, you're able to observe that the behavior was invalid and the output was invalid. Whereas in the case of error, it may or may not lead to a failure. And fault is, of course, the easiest of all of them. It is just that a mistake that is there in the code.
Yes. So that is, if failure happens, that definitely error has happened,
Of
but
course,
not vice versa.
and not vice versa. Exactly, because failure, intuitively, I think I mentioned that in the previous class also. Intuitively, it seems as if without the internal state being incorrect, it is close to impossible to get a failure, right? Until unless your internal state of the program becomes wrong in some sense, you're not likely to see a failure, right? So of course, error would happen first, and then only you go to failure. It cannot happen that directly from fault you go to failure without an error, you know, in between, right?
Yes, clear for me.
Okay. Anyone else? Any other questions, or can we close this?
Yes. Thank you.
All right. Thank you so much. All right. So that is that. Okay. Before moving forward and maybe closing for today also, I just
Yes,
want to,
that tour and
yeah. So if you,
something you said.
just take a look at this particular slide. No, this very nicely covers all of the things. So see what happens. I'll go through the definitions also, but see, just to capture it in one slide, what happens is that, okay, let the other things, yeah, okay. So see, in this case, this is my path. So this detour and side trip, please note that always happens in relation to a path. Okay, so you have an original path, let's call it P, right? So and in relation to that only, we'll see whether a side trip occurred or a detour, occurred, whatever, you know path we followed. I mean, whether it was a side trip or detour, but all of this in relation with a with some path that we're already testing. So let's say this is our main path. I'm calling it main path, but we just call it path, so that is P, but that's okay. So this is the initial node. We are going to 1, and then we are going to 2, From that we are going to 3 and to 4, and then we are going to 5. So this is the original path. So this is a prime path. That's okay, but that is not of concern right now. Whatever the current path is, we are just following that. And this is without side trip and detour, because that is the original path. We are just following that. Okay, so this should be clear. In this case, see what happens. So you go to from 1, you go to 2, you go to 3. Okay, but instead of going directly to 4, you go to 6 also. It's like a side trip, right? Your intention is to visit 5, but you visited 6 also in between, and you go to 6, you come back to 3, right, from 6, and then you again continue on your same path, right? So you go to 4 again and you go to 5. So in the original path, this one, 2, 3, 4, 5, and in the path with the side trip also, note that the order of the edges are same, right? So the edges that you are following are same as of the original path. So in P also, you followed this edge, these all edges, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. And in this side trip case also, you followed 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Only thing is that in between 3 to 4, you also went to 6 and come back to 3 again, and then you continued on the same path. Okay, so that is known as a side trip. Whereas in the last case, which is a detour, the difference is that you are going to have following all the nodes. So in this original path, we go to 1. Okay, look at what all nodes we are visiting. Okay, so we're going to 1, we're going to 2, we're going to 3, we're going to 4, and we're going to 5 in the original path. In this case also, we are visiting all of them, the nodes. In this case, we are visiting all of them, right? So we are also going 1 to 2, we are going to 3, we are going to 4 also, that's okay, and then we are going to 5 also in the detour case also. But note that the edges are not followed. It's like we are following a different path to reach all those nodes again, but the path is not the same as that of the original path. So if we change our path to reach the intended nodes, then we call it a detour. Whereas if we are not changing the path, but we are in between visiting additional nodes, then we call it a side trip, because note that we came back to our original path. But in this case, we did not came back to the original path. We go to 1 to 2, we go to 6, and then from 6 we go to 4 instead of going to 3 to 4. So in this case, we did not follow that 3 to 4 edge which was there in the original path. It was followed in the original path 3 to 4. In this case, in the detour, we did not follow 3 to 4. Instead, we followed a new path which was 6 to 4 and then to 5. So nodes are still being visited as in the original path, but our path itself is different. Whereas in the case of a side trip, we included additional nodes, but the path was the same, right? So we followed all those edges which were being followed in the original path also, no matter what we did in between. We are going to 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So that is the difference. Is the difference clear?
Yes, yes.
Okay. So let us go to the this thing also. So it says a tour is a test path. So this is just a tour. Okay, we're just talking about a tour. So in this case, what happens is that a test path P is towards subpath Q if Q is a subpath. Basically, that whatever path you have inside of one main path, that is there P. So if you have a path that is occurring inside of that, so in the set notation we'll have that all those nodes, and in between we'll have some other nodes that we visit, then we will call it a subpath, right? So for it to be a tour, it should be a subpath Q should be there. So that is the only thing, like for it to be considered a tour. Now tour can be of two kinds. One is of side trip, as visualized here, in side trip. In the case of detours, that is visualized in the third graph that is here. So the difference is that, again, a test path P towards subpath Q with side trips, if and only if, note that we are talking about edge here. Okay, in side trip we are talking about edge. Okay, every edge in Q, okay, in the other path. So this is Q. Okay, this was P, the initial path, the original path. This is Q. Okay, this is again Q. Okay, but we are following a different path here. So both of them are the same paths, but we are trying to see we are touring one with side trip, the other one with detour. So the tour is the same, the kind of tour changes. Okay, in these three. So in the case of side trip, as I was saying, if and only if every edge in Q is also in P in the same order. That is what happens. No, in this case, you see that In T we had 1 to 2, 2 to 3, 3 to 4, and 4 to 5. That is what happened in the side trip case: 1 to 2, 2 to 3, 3 to 4, and 4 to 5. But we also have something in between. That's okay. But we are following all the edges. So that is side trip, and that is what the definition says also. The tour can include a side trip as long as it comes back to the same node, and that is what
So
happens.
in detour, one of the single length path is missing basically.
Yeah, it could be missing. I followed something else.
No,
Entirely
no,
different.
it
Yeah.
actually misses in detour. Why? Because
Hmm.
3 to 4 is not being traversed.
Yeah, not being traversed.
So
Exactly. You're
that
not
is kind of missing now
missing. Yeah.
in detour.
Exactly. So it could be it could be missing this one or something else. Maybe it could be missing 2, 3, depending on what other routes are
Anyway, in
available.
this
Yeah.
case, it's
Yeah.
at least one path of length one is missing, then that is detour.
Yeah. Yeah. Okay. I mean, yeah, you can consider that. But then again, there's a very stronger. I'm sorry. There's a stronger reason to consider here. Every node also must occur, because you cannot say, let's say, for example, I mean, like, I go to from this is my original path. I go to 5. That's okay. I go to 1 to 2 to 3, and then I come to 6. Right. And from 6, let's say, I directly go to 5.
Directly
Okay.
to 5. So we cannot skip 4. That's it.
Right. Right. Exactly. So in that case, it is not a tour. It is not a tour at all. That is what. Because for it to be a tour, every edge must be followed. And of course, if you're following edge, you're already following a node, right? So if you're following the path, of course, you're going to touch the node as well. And in the case of detour, the condition is slightly relaxed. We just say that you have to visit the nodes that you intentionally, that you intended to visit initially. So that is what happens. If you're not visiting something, especially the node itself, then that would not consider a tour itself. So that is what it says. A dispatch P towards a path queue with detour if every node in queue is also in P in the same order. So if it is not there, every node is not there in queue in P in the same order, then it is not a tour at all, because then it will not be a subpath. You have to visit all. How are you visiting changes, but what are you visiting must remain the same. Okay, is that clear?
Yes.
All right. So actually, there was this question, graded assignment 2, question number 10. Somebody was asking previously, I think on this course, regarding the detours and side trips. So that's why I thought just cover that so that they can get benefited later on if they watch the recording also. And that is all. Yeah. With regards to the errors, faults, and failures, I think we have covered that was required. Anything else? Anything from week 1 or week 2? Okay. If not, then I think we can close as well.
I think if we can schedule one more session maybe on Saturday, because honestly, week 3 did not cover, I mean, did not watch even, because there could be some doubts.
Okay, open session, is it?
Yeah, live session like this.
Hmm. Okay, we'll try to arrange one. I'm not sure if mm, we can go in much detail, but yeah, okay, okay, I understand. So this is regarding specifically what topic would you like to be explained in more detail?
Week 3 topics, to be honest, they didn't start with week 3, but
Hmm.
assignment deadline is this Sunday, coming Sunday. So
Right, right.
session on Saturday or earlier maybe.
I see, I see. Before the assignment deadline, is it? Okay, yeah. So sure, I'll discuss with Sir also and see if we can
I
plan
put up
for
a
one.
request on Discourse also if need, or in the Google space.
Okay, yeah, sure, sure. Yeah, thank you so much. I think we can close the live stream now, sir, if you don't have anything else.
Thank you for the session.
Yeah, thank you. Thanks so much for attending and being here with us. So it is good that it becomes interactive, because otherwise what happens is that People join in sometimes, not a lot of people join in, but even if they join, if they don't ask questions, then it becomes very difficult for us to actually, understand whether the explanations that we are giving, are they
Avna,
making
shall I stop the streaming or?
something else? Yeah, sure, sir. I think we are done. We can close the live stream. Yeah, thank you all for joining.
Arup sir, I was saying, can we have a session maybe on Saturday or Friday
On what?
for week 3? I mean, after